Number 9 says find the local extrema for the function graphed in the figure below. This just wants to know, in looking at the graph, where does it appear that there is a maximum and where does it appear that it's a minimum. So they're looking for an ordered pair. So if I'm looking for a maximum, that's going to be where the graph tops out at, and so it looks like that's happening right here, and that's at the ordered pair 1, 3. And then for your local minimum, that's going to be down here, and our ordered pair for that is -2, -3. So those are your local maximum and minima. They call it local because you can see the graph keeps decreasing on the right hand side and increasing on the left hand side, but we don't know how far that is going up. Obviously there's going to be more points that are higher than 1.3, but just given the graph, the part of the graph that we're able to look at, those are the localized areas. So moving along, let's look at number 10. We're looking at composite functions. So they're giving us fog of x. And so what that means is, at least for the first part here, when we're dealing with the quote-unquote fog, or the f of g of x is another way that you might hear that said, or using function notation, is we're literally going to take the g function, and that's going to be our input into our f function. So we're going to have to take that and plug it into both parts there. So what is that going to look like? Well, so instead of x squared, I'm going to have 9x plus 1 squared. And then I have plus 5, and then my input again of 9x plus 1. So now I simplify this, and that's going to give me f of g of x. When I switch gears and go to GOF, or g of f of x, then I'll do the opposite, and I'll take the f of x, and it becomes my input for g. So let's go ahead and finish this problem out here. So 9x plus 1, that's going to be squaring a binomial. I like to go ahead and just expand it and use FOIL. I'm going to go ahead and distribute on this part of. So that's going to be 5 times 9x. So now let's FOIL. So I'm going to have 81x squared plus 9x plus 9x plus 1. And I still have this 45x plus 5. So I'm going to have 81x squared. When I combine all of my x's, I have a 9 and a 9. That's 18. 18 and 45 is going to be 63x. And then I have 1 plus 5, which is 6. And so this is going to be my fog. So all you do is start with, I think of it as my inside function. So the g is on the inside, so it's my input. My inside is my input into the other function. And then we'll do the same thing for the other half of the problem. But this time, I have to take x squared plus 5x, and that becomes my input into my g function. So my new function is going to be 9, and instead of x, I'm going to replace that with x squared plus 5x, and then I have plus 1. So let's simplify. So 9x squared plus 45x plus 1. And that's going to be my GOF, or my g of f of x. The next few problems, I'm actually asked to sketch a graph. So I'm going to switch over to my online graphing calculator. And if you want to use your own personal graphing calculator to do so, the nice thing about functions is they're already in quote-unquote y equals form. So you don't have to do any manipulating. You can just plug it directly into your graphing calculator. And so I'm going to go ahead and switch over. So In the next problem, it's number 11. We're asked to sketch a graph of x plus 4, and that's all being cubed. So we're dealing with a cubic function. So let's just get in our heads kind of what a cubic function looks like. So here I've just graphed a basic cubic function. So it's kind of this snake-like graph. So now if I go ahead and put in the function that I'm asked to put in, x plus 4, and that is all being cubed, how is that different from the parent function or that base function of x cubed? It's the same exact function. All that happened is it shifted to the left 4 units. So when you're doing with transformations, do you necessarily have to graph it? No, as long as you have an idea of what the graph itself looks like and you know what adding or subtracting does, then you have an idea. Now, don't get this confused with if it was x cubed plus 4. That gives us a different graph. The green graph, you can see that took our basic parent function and just moved it up 4. So when you're dealing with parentheses, it's moving it horizontally because the x is being affected. When there's no parentheses, then that means the y is being affected. So that's the difference between the two. So now you're able to look at your options and pick the graph that best resembles the graph that you have on your graphing calculator. So now let's look at number 12. Go ahead and delete those. It is the square root of x plus 3. So let's just put in our parent function of just a square root of x. So there's what just the basic parent function looks like of a square root. Again, it has to be above the x-axis because remember we're dealing with positive numbers here, so we can't have anything negative. We're dealing with real numbers. And the one that we're asked to find is square root of x plus 3. And now this put it all under one radical, which I definitely do not want to do because in the given function it's only the x. So I'm going to delete. I'm glad it did that so you can show the difference there. So I need plus 3 on the outside of the graph. There we go. So yeah, because the square root is only over the x and not the x plus 3, it's going to be a vertical shift up plus 3. So again, you can look at your options and choose the best graph that matches your graph. So really, this is just inputting those functions into your graphing calculator and just matching. The next problem says, use the graph of a transform toolkit function to write a formula for the resulting function. So because there's a squared in here, when it says toolkit function, that's that. If you go into the help, there's a PDF there of all of our basic graphs. I would recommend printing that off and having that with you to help you study. But you can see that there's a squared in this one. So this is a parent function of the parabola or just your squared x. So this is the basic function that we're dealing with. And you can see that we have an x minus 1 squared in parentheses and then a minus 4. The minus 4 is going to be a vertical shift up or down because it's not in parentheses. The minus 1 will be a horizontal shift because it's in parentheses with that x. So it's affecting the x. So we just have to decide what we're doing here. So if you look at this, this does not match the graph that I have. So how can I make it match? Well, I've got to go down. You heard me say earlier, there's a vertical shift happening. Obviously, it's moving down. So if I go in here and I just put that minus 4 there, that satisfies that condition. It shifted it down 4, so minus 4. Now there is a horizontal shift. So I am going to have in parentheses either a plus 1 or a minus 1 is what it appears to be. So if I do a +1 in parentheses, there's where it is. Well, it looks like it shifted it to the wrong side. I actually need it to shift right and not left. So let me just back up and change that to a -1. There. Now it looks like it's matching up, and I can double check some of those key points, like 3, 0. I see that's on my graph. -1, 0. That's on my graph. And 1, -4. Okay, so this is definitely my graph. So there is my function that goes along with it. X minus 1 in parentheses squared minus 4. Number 14, we're asked to look at a graph. They give us a graph, and then we have to decide if it's even, odd, or neither. Now, when you're talking about even, odd, or neither, that's referring to symmetry. So when we're looking at a graph, symmetrical means the same on both sides. So if it's an even function, that means it's going to be symmetrical around the y-axis. Okay, so y-axis. So what's on the left is a mirror image of what's on the right. Well, it's not going to be even, because if it was, our graph would actually come down like this, and it would be mirror image here. So definitely not even. So now, let me get rid of all these marks. Let's look at odd. Odd means it's going to be symmetrical around the origin, which means you're actually kind of looking at this as being your mirror image. Okay, number 15, we are asked to graph an absolute value function. So let's just get an idea of what an absolute value function looks like for us. And there it is. There's your basic function. If you were to look at your toolkit PDF, this is what you're going to see. So they want to know what the graph of the negative of the absolute value. So remember, negative means opposite. And that -3 means we're affecting the x. So it's going to be a horizontal shift. And there we go. You can see here are my two graphs. The red one is my original parent function. The blue one is the one we needed to see. So you can see that the negative on the outside is the opposite. It flips your graph upside down or flips it over the x-axis. And then the -3 is a horizontal shift to the right.